So let us now discuss about the resolving power of optical instruments. So I put up a heading over here, that is the resolving power. So don't get confused with the magnifying power. So magnifying power, as you know, so magnify means to enlarge the size of that particular object. But resolving power is associated with the distinction between two very close objects. Magnifying power and resolving power কিন্তু একই জিনিস নয়, এটা ক্লিয়ার করতে হবে আগে। Magnifying power is to enlarge the size বড় করার জন্য magnifying power, and resolving power is to identify two objects as separate objects. You see that very distant stars, আমরা যে তারা দেখতে পাই, very distant stars, many a times it happens that two stars are very close to each other, but when we view it from our earth, আমরা যখন আমাদের এখান থেকে দেখি, it appears to be a single star. এখান থেকে দেখলে একটাই তারা বলে মনে হয়, it appears to be a single star, but you see that it is actually not single, but there are two very close stars very close to each other, but that closeness has vanished in our view because we are viewing it from a large distance. কারণ আমরা সেটা অনেকটা দূর থেকে দেখছি বলে আমাদের কাছে সেটা মনে হচ্ছে. So that is why it appears as single object to us. And now in order to distinguish between two very close objects, the idea that is involved, that is the resolving power. And resolving power will help us to get a knowledge of how easily the two objects can be distinguished as separate with the help of some optical instrument. রিজলভিং পাওয়ার আমাদেরকে আইডিয়া দেবে যে কি করে দুটো খুব কাছাকাছি জিনিসকে আমাদের আলাদা বলে মনে হবে, হাউ ইট উইল অ্যাপিয়ার ডিফারেন্ট টু আস. So let us first of all define the resolving power. So whatever I have just spoken, so let me just put it in a formal way. If two objects are very close to each other, if two objects are very close to each other, or if they are at a very large distance, or at a very large distance from the eye, comma, then they may not be distinguished, as two separate objects. So then they may not be distinguished as two separate objects, right? That is we say that the eye cannot resolve them. We say that the eye cannot resolve them, right? Resolve মানে separate না করতে পারা. Resolution means to separate out, at least in this discussion. I don't speak about the dictionary meaning of resolution, but at least in today's class, resolve or resolution means to identify them as different objects. That is, we say that the eye cannot resolve them. And to resolve them, what do you need? To resolve them, optical instruments such as telescope, microscope. You see that these are also used for magnification. Within the microscope, you look over the biological objects, the view is magnified, and you get some ideas about those objects and their features, identifying characters you used to do under a microscope. But we use the microscope not for only magnification, but for our resolution purpose also, such as telescope, microscope. To resolve them, optical instruments like these are used, right? And it may also happen in particularly this happens in physics, that two very close wavelengths, ধরো কোনো একটা অবজেক্ট আছে, a object, an optical object emits light of two very close wavelengths. Now this actually happens in some atomic transition. ধরে নাও এটা গ্রাউন্ড লেভেলটা, this is the ground level. So now I am speaking something beyond optics, but I should say this for your proper understanding. So, and these are suppose two very close excited states, right? So এটা গ্রাউন্ড স্টেট আর এটা হচ্ছে তোমার এক্সাইটেড স্টেট, দুটো এখানে আছে. এবার এখানে একটা ট্রানজিশন হলে you know that if there is a transition, so there will be, you know this from the Bohr's theory, that h nu equals to e2 minus e1. So nu corresponds to some frequency. Let the frequency some frequency nu, and then there is some wavelength, that one I call lambda. And there is another transition over here, and this is associated with some lambda dash. Okay, this is my ground state, and these are the two excited levels very close to each other, very close to each other. Thora now 2 angstrom, 3 angstrom, that difference. Now if this difference lambda dash minus lambda, suppose, so this lambda minus lambda dash, so this difference you suppose only 2 angstrom, that means that the two lines are very close to each other. এই দুটো লাইন কিন্তু খুব কাছাকাছি থাকবে in the wavelength spectrum. In the wavelength spectrum, these two lines will be very close to each other, very close to each other. এই দুটো লাইন অত্যন্ত কাছে থাকবে. These two lines will appear very close to each other, and by naked eye it will be very difficult for us to distinguish them as separate. আমাদের খালি চোখ মনে করবে এখানে একটাই লাইন আছে. So our naked eye will suppose that there is only one light of some wavelength lambda, but actually here you have a light of wavelength lambda, and there is another line at the separation of d lambda, which is of 2 angstrom. So in order to separate these very close wavelengths, that cannot be done by telescope or microscope. Telescope, microscope can separate out some biological objects, some celestial objects. Celestial objects means the stars, or you see the other objects in the universe, other than the stars. Stars ছাড়াও যে বাকি যেগুলো আছে, I don't know what exactly, some comets or something like that. So এদেরকে distinguish করার জন্য আমরা এই telescope and all these can be used, and microscope for some very small objects, to separate them you may use them. But to separate out wavelengths we need gratings and the prism. So prism দিয়ে তুমি জানো what actually a prism does. So a set of wavelength when incident, don't consider white light ছাড়াও ধরো একটা set which consists of two wavelengths, lambda and lambda dash. This consists of two wavelengths এখানে আছে. So then it will be appeared as separate due to the dispersion. So dispersion এর জন্য দুটো আলাদা লাইন তুমি দেখতে পাবে. You will see two different lines, theoretically two different lines. And now to see them as two different lines, দুটো different যাতে আমি চোখে দেখতে পাই, so they should not appear very close to each other and a single line. And that can be done easily with the help of the resolving power of this type of instrument. So better the resolving power, so better is the instrument to distinct two very close wavelengths. So that is also we write it over here on the next paragraph. So next line আমরা এটাও লিখে দিচ্ছি যে similarly to distinguish two very close spectral lines, optical instruments like as prism, grating, optical instruments like prism, grating, etc. are used. So telescope, microscope are used for which purpose? Telescope, microscope are used to separate two very close objects, and prism and this grating is used to separate two very close wavelengths, spectral lines, wavelengths. Okay, spectra means that atomic transition that yields some spectra. So we are speaking of those quantities over here. তো তাদের কথা আমি বলছিলাম। তা ঠিক আছে, এইটুকু অবধি আমরা বুঝে গেলাম যে রিজলভিং পাওয়ার অ্যাকচুয়ালি কি করব, what we are trying to do. And in our syllabus the eye cannot resolve them. This resolve I underline because this is the most important word in today's class. And in our syllabus we have this telescope and we have this grating. So আমাদের সিলেবাসে আমার টেলিস্কোপ আর গ্রেটিং এই দুটো জিনিস আমাদের সিলেবাসে আছে. So one is from the instrument case and another is for the spectral line separation. So one is for the to resolve the objects, we have the telescope, and one from the spectral line case, that is the grating. So এই দুটো আমাদের কাছে আছে. And the telescope, as I was speaking that in the class during the discussion of my circular aperture. So when I was discussing circular aperture, I said that a telescope has a circular aperture. So that particular techniques and the theory which you learn in circular aperture will be applied over here to calculate the resolving power. So now when do you consider that two objects are resolved? এবার আমরা কখন আমরা কনসিডার করি যে দুটো অবজেক্ট আমাদের রিজলভ আছে? So that is what is given by Lord Rayleigh, and this is known as the Rayleigh's criteria of resolution. So this is called the Rayleigh's criterion. So the next one I write over here, Rayleigh's criterion of resolution. Rayleigh's criterion, singular criterion, Rayleigh's criterion of resolution. So what Lord Rayleigh said about the resolution. So for this you see that I need so let me write the statement first, and then I will import two optical diagrams over here that I have taken from some standard books. 2-point objects or two very close spectral lines, 2-point objects or two very close spectral lines, 2-point objects or two spectral lines very close to each other, are said to be just resolved, if the central maxima central maximum in the diffraction pattern, actually when I write central I should write maximum, because central maximum is the singular, maxima is plural, so central e to ektai hoy, only one, so actually theoretically I should write maximum instead of maxima. If the central maximum in the diffraction pattern of one falls on the first minimum, falls in the first minimum in the pattern of the other, if the central maximum in the diffraction pattern of one falls on the first minimum in the pattern of the other. So that is the Rayleigh's criteria of resolution. So Rayleigh এটা বলছে, এটা আমাদেরকে বুঝতে হবে। So this has some immense physics within it. So এর মধ্যে অনেক physics ব্যাপার আছে, তো সেটা আমরা এখানটাতে বোঝার চেষ্টা করব। So that is what we will try to understand next. And for this I need to borrow some diagrams. So give me some minute. So let me borrow that diagram which I have already taken snapshot from some standard textbook. So I have taken one of them. This is the first one that I take. Then I will take another one. It's another one that I take. Okay, so this is about the resolution that we are actually speaking of. So এই resolution এর কথাই আমরা এখানে যে বলছি, এবার একটু ভালো করে দেখে নাও সেটা. So you just have a look over here. So you see that there are two patterns over here as you can see. So এখানে দুটো প্যাটার্ন দেখা যাচ্ছে, ভালো করে খেয়াল করে দেখো, এখানে দুটো প্যাটার্ন দেখা যাচ্ছে. You can see two patterns over here. One is by the continuous line, এই যে এইটা একটা continuous line. So this is one of the pattern like this one. And this dotted line is your another pattern, আর এই dotted line যেটা দেখতে পাচ্ছ এটা কিন্তু আরেকটা প্যাটার্ন. So there are two patterns that you can see in this particular diagram, right? And these two patterns are from two different objects. You see that it has been written, এখানে লেখা আছে diffraction from one object, and this dotted one is the diffraction from another object. Okay, and here a resolution occurs. Look at these two diagrams simultaneously. দুটো ডায়াগ্রামে একসাথে তুমি তাকিয়ে দেখো, and there is another third line also over here. Third line টা হচ্ছে এই যে এইটা, this resultant intensity line, the deepest one, সবথেকে ডিপ যেটা আছে সেটা হচ্ছে এই যে এইটা, the deepest line over here, the deepest line, সবথেকে যেটা deepest one, right? So this is the resultant pattern. Actually there are two pattern, one is solid, one is the solid, one is the dashed one, and then this one actually যেখানে ডিপটা লেখা আছে, this one, so this line is the resultant of both of them. So এটা হচ্ছে the resultant of both of them. Okay, so that is how the system moves on and what is actually happening. So this one I call just resolved. এটা কিন্তু just resolved হয়েছে following the Rayleigh's criteria. This is just resolved, this is not resolved, this is not resolved. Okay, এখানে তুমি দুটোকে আলাদা বলে তুমি চিনতে পারবে না, you cannot identify these as two different objects because you see that these two maximas are very close to each other. এখানে তুমি খেয়াল করে দেখো এই ম্যাক্সিমা দুটো এত কাছাকাছি কেন আসলো, why the two maximas are very close to each other. The two maximas are very close to each other over here, the two maximas are very close to each other over here because the two maximas are very close to each other over here because the two objects are very close. এখানে objects গুলো খুব কাছে ছিল, the two objects are very close and that is why their maximas are also very close. And when you look at them, they don't appear to be two different objects. এখানে দুটো আলাদা প্যাটার্ন তুমি দেখতে পাবে না, you will be unable to find two different pattern over here, rather you will find only a single pattern like this. একটা single pattern তুমি দেখতে পাবে which is the combination of these two, একটা single pattern which is the combination of these two. So that is what you can find over here, right? So এরকম একটা প্যাটার্ন তুমি দেখতে পাবে. So concentrate on the blue line. So this blue line actually shows you that there is only one pattern and this is not resolved. এটা কিন্তু resolution হয়নি, the optical instrument has failed to resolve this, right? The objects are very close to each other and this is by virtue of naked eye. So naked eye এটা তোমাকে করে দিতে পারবে না. So this is not a resolution, right? So you understood this problem, but excuse me, but you look at the blue pattern of this one. এইটার blue patternটা দেখো, you see that the blue pattern of this one, you look at the resultant intensity only. So you find a deep over here, so এখানটাতে একটা deep দেখা যাচ্ছে, তাই না? You find a deep over here and then again it moves on, right? So এইটা এরকম ভাবে আসছে. Now the deep that you find over here, that is the matter of interest in this particular discussion. এই যে ডিপটা তুমি যেটা দেখতে পাচ্ছ, এই ডিপটাই হচ্ছে এখানকার ম্যাটার অফ ডিসকাশন. So this deep actually shows you that something has happened. তুমি দেখতে পাবে এইদিকে লাইট আছে, you will see that here you have maximum light, here you have maximum light, and in between the light has diminished. এর মাঝখানে লাইটটা কমে গেছে, the light has diminished over here, and that is why the two maximas will be very much clear to you. সেই জন্য এই দুটো ম্যাক্সিমা তোমার কাছে কিন্তু আরো বেশি করে ক্লিয়ার হবে. As I used to say in the classes of interference also, the maximas will have more and more clarity if the minimas are of zero intensity, right? So actually the importance of light is understood when there is no light. So আলোর গুরুত্ব তখনই বুঝতে পারবে যখন অন্ধকার থাকবে, right? So we used to see, so this is the proverb. So এরপর বলে থাকি, so আলোর গুরুত্ব, the presence of light, you will understand the importance of it only if there is some darkness in the surroundings এ darkness থাকলে তখনই তুমি সেটা বুঝতে পারবে that how important is that. Okay, just similar to you have two rooms in your house and one of the light has got fused, একটা light fused হয়ে গেছে, so from the evening you will not visit that room. So তুমি তো সেই ঘরে আর যাবে না, you will not visit that room because that is having no light at all. তো সেটা অন্ধকার রুম, তুমি সেখানে যাবে না. So this shows you the importance of light. So all the household members are in a single room, সবাই একটা ঘরেতে আছে. Why? That's the importance of light. So the importance of light is understood when there is no light. The same things appears here also. এখানেও একই কথা, এখানেও একই কথা. কথাটা হচ্ছে তুমি দেখো এখানে তুমি বুঝতে পারবে না যে দুটো আলাদা প্যাটার্ন আছে. Here you will not understand that there is two different pattern. Why you will not understand? It's very simple. You will not understand that there are two different patterns. Why you will not understand? You will not understand because you see that these are very close to each other. There is no such deep. এখানে কোনো deep তুমি পাবে না, এরা এতই কাছে, এর deep তুমি পাবে না. There is no deep. But here you find that deep. And this deep is the reason. So এই deepটাই তোমাকে বলে দিচ্ছে. So deep মানে কি? There is something high intensity on the left and right. এখানে কমে গেছে. Here it is a decrease. So there is a maximum and there is a maximum over here. So these two maximas will appear clearly to you. So এই দুটো maxima তোমার কাছে clearly আসবে। আর দুটো maxima কেন এসছে? Why there are two maxima in the diffraction pattern? So once you see two maxima in the diffraction pattern, you should understand that it is due to whom? দুটো maxima দেখতে পাচ্ছ। So you should understand that these two maximas are due to two different objects. And you see that why the deep actually appears. So first of all, you see that there is a deep. The deep helps you to understand that there are two maxima. And now the question is why the deep? এই ডিপটা কেন আসলো? Why a deep is there in that particular situation and not here? এখানে ডিপটা নেই, but এখানে ডিপ আছে। Why? Because you see something has happened over here. You see that you just note it very carefully that when this one has a maxima, this continuous line, a continuous line এর যখন maxima আছে at this position, then you see that this dashed line has a minima at that point. সেখানে কিন্তু এখানে একটা মিনিমা আছে। বোঝা যাচ্ছে কথা? মানে যখন একজন ম্যাক্সিমাম দেখাচ্ছে তখন আরেকজন কিন্তু কমপ্লিটলি জিরো আছে। দ্যাট ইজ হোয়াট ইজ দ্য আইডিয়া ওভার হিয়ার, এন্ড দিস হ্যাজ বিন আইডেন্টিফাইড বাই লর্ড র্যালে। র্যালে বলছেন যে যখন একজন ম্যাক্সিমা দেখাচ্ছে তখন আরেকজন কিন্তু কি দেখাচ্ছে? মিনিমা দেখাচ্ছে। এন্ড দ্যাট শুড বি ডেফিনেটলি ফার্স্ট মিনিমা, বিকজ দে আর ভেরি ক্লোজ টু ইচ আদার। এবং সেটা ফার্স্ট মিনিমা হতে হবে ইফ ইউ ওয়ান্ট জাস্ট রেজলিউশন। মানে জাস্ট তুমি আলাদা বলে মনে হচ্ছে, ইট অ্যাপিয়ার্স ডিফারেন্ট টু ইউ, জাস্ট ইট অ্যাপিয়ার্স ডিফারেন্ট টু ইউ। Right? Understood? And similarly এই সাইডেও দেখে নাও, you see for this dotted one also, when the dotted one shows a maxima that is at this point, so then you see that the continuous one shows a minima. ভালো করে বোঝো, when the continuous line মানে this line shows a maxima, so then this dotted line shows what? It shows the minima. And when this dotted line, when the dotted line shows a maxima, so then you see this continuous line shows a minima. তার মানে একজনের ম্যাক্সিমার সময় অন্যজন কিন্তু মিনিমা দেখাচ্ছে। when one of them shows maxima, then the other one shows minima. when one of them shows maxima, then the other one shows the first minima actually, because they are very close. So first minima, and this is why they are resolved. You obtain a deep. The deep means drop in intensity, মানে এক জায়গায় ড্রপ আছে আর দুই দিকে দুটো হচ্ছে maximum intensity. On the two sides you have intense light, and in the mid position you have very less light. So this confirms that you have two patterns. তার মানে ওখানে দুটো অবজেক্ট আছে, কেননা দুটো ইন্টেন্সিটি, there are two maximas with a deep. And here you see that the two maximas, you see that in this case the maxima, when one of them reaches the maxima, the other, so there is no minima of the other. When one of them, this one reaches maxima, the continuous reaches maxima, so then this dotted one don't have a minima at this point. তখন কিন্তু এই যে যেটা ডটেড লাইন আছে, the dotted one don't have a minima at that point, which was the case in the previous one, right? So একজনের ম্যাক্সিমার সময় আরেকজনের মিনিমা ছিল না on the right side diagram, right? So that is why it is not resolved. সেই জন্য এটা রিজলভ হয়নি, that is not resolved. I hope that the situation has been well explained and well understood by us. আমরা নিশ্চয়ই পুরোটা বুঝতে পেরেছি। Okay, that's fine, fantastic. We are happy with our understanding. তার মানে deepটা খুব important. The deep is very important. That helps us to identify two distinct objects. And the deep actually appears because the maxima of one falls on the minima of the other. And this is another diagram you can draw over here. So এটা আরেকটা ডায়াগ্রাম তুমি এখানে ড্র করতে পারো, সেটা হচ্ছে তুমি ধরতেই পারো যে এরকম এটা একটা প্যাটার্ন, দিস ইজ ওয়ান অফ দ্য প্যাটার্ন। This is one of the pattern, and you may go for another one with another color. The width is too much. I am not able to draw it correctly. Okay, this can be extended like this. And this one, you see, this diagram, this is not too essential. এটা খুব বেশি জরুরি নয় এটা। Here you see that this is well resolved because the two objects are separated by a very great distance. So এখানে কিন্তু তোমার রেজলিউশনের কোনো ব্যাপারই নেই। So here by a naked eye only you can view these two patterns. So এখানে তুমি এমনি দুটো প্যাটার্ন দেখতে পারবে. So this is well resolution, right? This is no resolution. এটা হচ্ছে just resolution. Just resolution কখন? When the first maxima, when the central maxima falls on the first minima, and this one, so this one is beyond everything. এখানে always resolved. So this one is always resolved. Always resolved. Understood? কেন এখানে? Because here the separation is very large. এখানে দুটোর মধ্যে সেপারেশন দেখো অনেক লার্জ আছে, right? So there are many dips, so there you can see many number of dips over here, so the things are very much easily tractable over here. So এখানে আরো বেশি easily track করতে পারবে তুমি, because you see that the two maximas are well separated. দুটো ম্যাক্সিমা কিন্তু দেখো অনেকটা সেপারেশন আছে, কিন্তু there is a well separation between the two maximas, so there is no question of resolution. This will be automatically resolved. এটা automatically resolved হয়ে যাবে, right? So this is automatically resolved. You don't have to be doubtful about the resolution of this. আর এটা যেরকম not at all resolved, this is just resolved, মানে এটা critical condition, এই যাই অবস্থা, এটা হচ্ছে critical condition, right? আর এইটা, so this one and this one is always resolved, right? Because they are hugely separated, অনেকটা resolved আছে. So আশা করা যায় তোমরা বুঝেছো, বাকিটা বই থেকে পড়বে, the other things you will read from the book and try to understand the issues. So পরীক্ষায় আসছে কোশ্চেন থাকে যে Rayleigh's criteria of resolution, what do you mean by Rayleigh's criteria? So you have to write it and explain it by virtue of the diagram. So whatever I have said or I have spoken, so these things are written on the books, well established on the books, so you write it from the books, because I am not going to waste time by writing the things just by copying from the books. So বই থেকে কপি করে আমি আর সময় নষ্ট করব না, আমি তো এক্সপ্লেন করে দিয়েছি that the main thing is that the first maximum of one, sorry, the central maximum actually, the central maximum in the diffraction pattern of one must fall on the first minima of the other, and then it will be just resolved. And if the distance is more, just like this third diagram, এটার মতন যদি আরো বেশি ডিসটেন্স হয়, বেশি হলে তো কোনো অসুবিধা নেই. If it is more, then I have nothing to say. বেশি হোক না, কোনো অসুবিধা নেই, I have nothing to say, but it should not be less than that. The first maximum should fall on the first minimum of the other. Central maximum should fall on the first minimum. Okay, ঠিক আছে. So now whatever I will try to do is that I will try to find out the resolving power of my telescope and grating as per our required syllabus. So আমরা এই দুটো জিনিসের resolving powerটা বের করতে চাইছি. One is for the telescope and another is for the grating. The telescope one is very simple, you have no calculation at all, you can just find it, and the grating has some job that should be done over here. Let us try to go for it. Okay, so the next discussion, as you can see, it is the resolving power of telescope. Let me define it. Resolving power standard, you can write RP, no problem. The resolving power of a telescope, there is no such standard definition, you will understand. The definition is just to distinguish the two objects, so that you can define in your own way. So I will show you. The resolving power of a telescope is defined as the inverse of the smallest angle subtended at its objective by two distinct close point objects, by two distinct close point objects that can be just recognized as separate. The resolving power is defined as the inverse of the smallest angle subtended at its objective. Objective means the lens of the telescope. The objective, you know, the lens. A telescope actually has two parts. Telescope এর দুটো পার্ট থাকে. A telescope has two parts. So this one is your objective, মানে এটা হচ্ছে অবজেক্টটা, the object on which you focus. So that side is called the objective, and this side is the human eye. এটা মানুষের চোখ থাকে. So this is the human eye. So this side is called the eyepiece. So actually a telescope has, or a binocular has, two lens. One is the objective lens system towards the object, and then there is the eyepiece. So এখানে থাকে হচ্ছে eyepiece towards the eye, and this is movable. So এটাকে মুভ করে we can focus it. By movement we can focus it properly. So here I call it the objective. The resolving power is the inverse of the smallest angle subtended at its objective by two distinct close point objects that can be just recognized as separate. ওকে, ডেফিনেশন আই উইল বি ডিসকাসিং এট এ লেটার স্টেজ, ডেফিনেশনটা আমি পরবর্তীতে ডিসকাস করব, এখন করছি না। সো এখন আপাতত আমরা এই টেলিস্কোপের যে সিস্টেমটা আছে সেটাকে আমরা একটু আলোচনা করব, দ্যাট ইজ হোয়াট আই এম গোয়িং টু ডিসকাস নেক্সট। সো দিস ইজ দ্য টেলিস্কোপিক সিস্টেম। সো দিস ইজ দ্য টেলিস্কোপিক সিস্টেম। It's a combination of convex lens, concave lens. Don't ask me why, because that is the discussion, that is a different discussion of telescope, that why do I have two different lenses. That's a complete different thing, which I am not going to deal at the present moment. So this is one of the diffraction pattern that I have drawn. So এটা হচ্ছে একটা diffraction pattern যেটা আমি এখানটাতে draw করলাম। Just let me try to draw in a better way, because as I used to say that the diagrams speak a lot in optics. ছবি অনেক কথা বলে এখানে, তো ছবি ভালো করে করা দরকার। And you suppose that there is another system, although I use different color, but still I use the different ray diagram also. At the time of exam you don't have different colors, তোমাদের তো different colors নেই, so you have to use two different types, that is the dotted and this one. Better I take it to here. Yeah, fantastic. Yeah, fine. Yeah, fantastic. This is the screen system. So on the screen I obtained the diffraction pattern due to two of the lights over here. So দুটো লাইটের diffraction pattern ধরো আমরা এখানে নিচ্ছি, আমার এটা ঠিক পছন্দ হচ্ছে না, this one, this red one is not appearing suitable to me. Okay, now I am bit more satisfied. Okay. So you see that there are two objects. So this black one is coming from O1. So black টা আমার আসছে O1 থেকে, and the red one is coming from O2. So these are the two stars you say which are located at a long distance, at infinity. So এই দুটো হচ্ছে, and that's why the rays are parallel. You may say that, sir, why the black rays are parallel and why it is not a point. So এটা point নয় কেন, because it is coming from a single point, right? So O1 is a single object. So that is why what I want to say is that this is a ray and this is another ray that is coming over here. And if you see that, if you look at a large distance, if you take a small portion, অনেকটা দূরে গিয়ে তুমি যদি একটা small portion নাও এরকম, you just reject the left hand side portion of it. So if you just take these two elements, so you see that they appear to be more or less parallel to each other. দেখো মোটামুটি parallel মনে হচ্ছে, right? And they are coming from the same object O1. তারা কিন্তু একই object থেকে আসছে O1, right? And these are the two rays that you see, this one and this one. And that is why, because they are coming from large distance. So if the rays are coming from large distance, even they are coming from a point object, so then also they appear to be what? So then also they appear to be separated as parallel lines, because they are coming from infinity. So infinity থেকে আসছে, সেজন্য তুমি বলো না যে স্যার একটাই পয়েন্ট থেকে আসছে তো দুটো রে কি করে হলো? So from single point how do I get two rays? The simple answer is they are coming from infinity, and that's why they are parallel also. And now from O1, this is an aperture. You see, this is a circular aperture. এটা একটা circular aperture, and now this circular aperture forms two of the patterns. So one of the pattern is P1 and this pattern is P2. So there are two patterns formed over there. One is the pattern P1. So P1 is the central maximum of O1 and P2 is the central maximum of O2, right? P1 টা হচ্ছে O1 এর যে সেন্ট্রাল ম্যাক্সিমাম সেটা, আর P2 টা হচ্ছে তোমার O2 এর যে সেন্ট্রাল ম্যাক্সিমাম সেটা এখানে দেখানো হয়েছে। দ্যাট ইজ হোয়াট আই হ্যাভ শোন ওভার হিয়ার, এন্ড দিস অ্যাঙ্গেল আই কল ইট সাপোজ d থিটা, এবং এখানকার যে অ্যাঙ্গেলটা হয়েছে, সো আই ইউজ আ ম্যাজেন্টা কালার and this angle I call it suppose d theta, so এটাকে আমরা d theta অ্যাঙ্গেলে বলছি, মানে এদের মধ্যে অ্যাঙ্গুলার সেপারেশনটা হচ্ছে d theta, right? Is it clear to you? And d theta is very small, and under this smallness, if my instrument is able to detect it, এত ছোট হওয়া সত্ত্বেও, even after this smallness, my instrument is able to detect it as two different objects, so then I will call it well resolved, and my instrument has a good resolving power. That is what is the idea. সিম্পল টাস্ক আছে, কোনো ম্যাথমেটিক্স নেই, জাস্ট এক লাইন ম্যাথমেটিক্স আছে, তা বুঝে যাবে এখন, ইউ উইল আন্ডারস্ট্যান্ড ইন আ ভেরি ভেরি সিম্পল ওয়ে। লেট আস গো ফর, সো দেখিয়ে দিচ্ছি। উই কনসিডার এ টেলিস্কোপ, টেলিস্কোপের ডায়ামিটারটা আমাদের লাগবে। উই কনসিডার এ টেলিস্কোপ that is diameter of this aperture. We consider a telescope of diameter, consider a telescope of diameter capital D. Stop. O1 and O2, O1 and O2 are two distant point objects, because from large distance it appear to be a point, are two distant point objects. You see that we look at the stars appears to be a points only to us, are two distant point objects from which, আমরা দূর থেকে তারা দেখলে একটাই ছোট জিনিস মনে হয় সেরকম, from which parallel rays are incident, parallel rays are incident on the telescope, at an angular separation of how much? D theta. At an angular separation of d theta. Fine. The telescope objective means that blue lens system. The telescope objective acts as a circular aperture. The telescope objective acts as a circular aperture, and hence form diffraction pattern for O1 and O2. Okay, তাহলে তুমি কি দেখতে পাবে? ডিফ্রাকশন প্যাটার্ন দেখতে পাচ্ছ। You can see diffraction pattern on the screen. Which is important. You can see diffraction pattern on the screen. So light from O1 is incident on the circular aperture, then there is some diffraction, maximas and minimas like this, Light from O2 is also incident, and for that one also you have maximas and minimas. So two different colors, magenta and black for the two, that is O1 and O2, and P1 and P2 are the positions of the maxima of either of them. So P1 P2 হচ্ছে তাদের যে সেন্ট্রাল ম্যাক্সিমাম গুলো সেইগুলোর পজিশনটা হচ্ছে এইটা। The pattern for the, I have already shown you the pattern in a circular aperture. Circular aperture এর প্যাটার্ন অলরেডি বলে দেওয়া হয়েছে, just like the single slit. So those patterns are formed on this screen. তো সেই প্যাটার্নটাই স্ক্রিনের মধ্যে তৈরি হয়েছে, আর কিছুই না। এই হচ্ছে স্টোরিটা তোমার, ঠিক আছে? এখানে লিখে দিচ্ছি P1 and P2 are the position of the of this maxima actually. P1 and P2 are the central maximum. P1 and P2 are the central maximum of O1 and O2 respectively. P1 and P2 are the central maximum in the diffraction pattern, of O1 and O2 respectively. P1 and P2 are the central maximum in the diffraction pattern of O1 and O2 respectively. So that is what I find over here. ঠিক আছে, বোঝা গেছে? Okay, the patterns will be now just resolved. So now what is the condition of resolution? এবার কথা হচ্ছে রেজলিউশনের কন্ডিশনটা কি? What is the condition of resolution? The patterns will be just resolved. কখন হবে just resolved? Will be just resolved if the central maximum of one falls in the first minimum of the other, and this is what is known as the Rayleigh's criteria of resolution. Rayleigh's criterion of resolution. This is the Rayleigh's criterion of resolution. That is, তার মানে হচ্ছে, that means that is that is P2, that is P2 must be what? P2 should be, that is P2 should be what? P2 should be what? P2 should be the position of the first minimum. P2 should be the position of the first minimum. P2 should be the position of the first minimum due to O1. P2 should be the position of first minimum due to O1. Right? বলো বুঝতে পেরেছো কি? P2 টা actually কার position? P2 is actually the position of what? P2 is actually the position of principal maximum of O2. And what did Lord Rayleigh said? Rayleigh কি বলছেন? Rayleigh বলছেন that the system will be resolved if the principal maxima of one falls on the first minimum of the other. So this is the principal maximum of P2 already. এটা কিন্তু principal maximum. P2 is the principal maximum of O2. তাহলে এটার উপর কাকে আসতে হবে? Who has to overlap on it? This should be also, this P2 should also be the position of what? কার position? This should be the position of first minimum. This should be the position of first minimum of O1. I hope you got it. তাহলে P2 টা হচ্ছে position of principal maximum. Principal maximum, হ্যাঁ P2 টা principal maximum কার জন্য? For whom? For O2. And at the same point there should be the first minimum due to O1. And then the Rayleigh's criteria is satisfied. তখন Rayleigh's criteria satisfied হবে. There will be that deep that I have been discussing. যেই ডিপের কথা বলছিলাম সেই ডিপটা থাকবে, and then object will appear to be separate or it will appear to be resolved. Hopefully you got it. আশা করি বুঝতে পেরেছো। ঠিক আছে? তাহলে P2 যেটা কিনা position of the central maximum of P2 of O2, P2 the position of the central maximum of O2, at the same point you must have the first minimum of P1. ওই সেম পয়েন্টে তোমার ফার্স্ট মিনিমাম অফ P1 টাকে থাকতে হবে, রাইট? that is the understanding over here. Now what is the condition to get first minimum in case of a circular aperture? Circular aperture এর ক্ষেত্রে ফার্স্ট মিনিমাম পাওয়ার কন্ডিশনটা কি? What is the condition to get the first minimum in case of a circular aperture? In case of a circular aperture. So you know it? Do you know it? Definitely you know it. You have studied circular aperture. So lekho the condition for first minimum, the condition for first minimum in the circular aperture, the condition for first minimum in the diffraction pattern, in the diffraction pattern of the circular aperture is, you have learned it, you know better. The condition is কি ছিল রে? একটু মনে করো, মনে পড়ে যাবে এখন. You will remember definitely. The condition was sin theta, the first minimum you understand, it was 1.22 lambda by capital D. মনে পড়ে? This was the condition. In my case the theta will be replaced by d theta because I have taken that angle to be very small. So I have taken it d theta to show you the smallness. So sin of d theta is equals to this. Or I can write d theta is nearly equivalent to this one. Right? So this d theta is equals to 1.22 lambda by capital D. You understand it very well. It's just condition. Circular aperture condition ছিল তো এটা। এটার পরেরটা ছিল না 2.233 lambda by capital D. This was the condition of the second minima. আমি এটাকে সার্কেলে করে রেখেছিলাম। In my treatment of circular aperture I have circled this. I have said that this will be used. So first minima. So first minima condition টা কি? এটাই first minima condition. So that is why I write it. আর এটা কেন করলাম? Since d theta is small. Smallness এর জন্যই তো যত সমস্যা. So who is the culprit? The smallness is the culprit, and that is why it is not appearing to be separate. So that is all about what I obtained. And by definition the resolving power is defined as 1 by d theta. Now you will ask that, sir, why? I will answer. So the resolving power is d divided by 1.22 lambda. You may practice some numerical examples from here, and to solve the numerical examples you need the help of this formula, this d theta. This d theta will help you to solve numerical example. This is just the inverse of it. Power টা এখানে important না, the power is not important. So why do I call it in the inverse sense? You see that, আচ্ছা বলো তো কখন আমি ইনস্ট্রুমেন্টটাকে বেটার বলবো? When will I call my instrument better? When d theta is small or when d theta is large? When will I call my instrument better? When d theta is large or when d theta is small? So definitely when d theta is small you will call it a good instrument. d theta যখন small তখনই তো তুমি good instrument বলবে এটাকে, because it can separate very small So smaller the value, better is the instrument. Smaller the value, better. Smaller, down arrow মানে smaller, smaller d theta, better resolution. Because যত ছোট থিটাকে রিজলভ করতে পারবে, smaller and smaller theta it can resolve, I will call it a better instrument, right? And in sense of power, whom do I call better? The more is the power, the better is the instrument, right? But এখানে কি হচ্ছে, smaller is the value, better is the instrument, জিনিসটা বোঝো, হ্যাঁ? Smaller is the instrument, smaller is the value d theta, better is the instrument. d theta যত small হবে তত বেশি ভালো ইনস্ট্রুমেন্ট হবে। বাট ইট ইজ আ নর্মাল হিউম্যান কনসেপ্ট। তো মানুষের একটা কনসেপ্ট থাকে যে যত বেশি তত ভালো, তাই না? আমাদের কনসেপ্ট কি হয়, যত কম তত ভালো তো হয় না, তাই না? আমরা বলি যে যত ভালো, যত বেশি তত ভালো। সো বেটার ইজ দ্য মার্কস, গুড ইজ দ্য স্টুডেন্ট, বেটার ইজ দ্য, মোর ইজ দ্য মানি, দ্য পাওয়ারফুল ইজ দ্য পারসন, রাইট? সো সবসময় বেশি, অলওয়েজ মোর অ্যান্ড মোর powerful. So by the power we need, we mean excess. Power we means more. So that is why I have taken the inverse. So if d theta is smaller, so you understand that 1 by d theta will be what? Greater. D theta smaller, কিন্তু 1 by d theta is greater. So that is why the resolving power is defined in this way. Because greater is the resolving power. So resolving power is 1 by d theta. D theta যত small তত ভালো, smaller d theta, better is the instrument. So smaller the d theta, greater is the resolving power and better is the resolution. Okay, because power is just a magnifying power. You see that when you go to the market and buy microscope, 10x, 20x, 50x, 100x microscope. So a 100x মানে 100 is the power. So 100x is better than 10x. Okay, 100x is better than 10x. The more the power. So এখানেও তাই, the more the power, the better is the resolution. So that is why we define it in the inverse way, right? But the basic idea you should understand, কিন্তু basic idea টা হচ্ছে যত ছোট d theta resolve করতে পারবে তত ভালো instrument. The smaller d theta it can resolve, the better is the instrument. Okay, that's it about the resolving power. You see that you don't have to do any mathematics. All the mathematics are borrowed from the circular aperture, and this is the reason that I need to teach you circular aperture, although I need to use the Bessel's function which is not in your course. Okay, so that's the reason, because this is the important question at the time of exam, that find the resolving power. What do you mean the Rayleigh's criteria of resolution? 2 marks. And then find the resolving power of a telescope, 3 to 4 marks, and then a problem. So this makes a complete sense of a question, right? So next I will go for the resolving power of a grating. The next one. Okay, so I put the next heading now, that is the resolving power of a grating. And this discussion will conclude our discussion on diffraction, in front of our diffraction, and also the resolving power. And after this we can move on to the Fresnel type of diffraction. So resolving power of a grating. আচ্ছা, grating এর resolving power হচ্ছে the ability to separate two spectral lines. The resolving power of a grating is defined as its ability. This is universal definition. It's always the ability to distinguish two objects or two spectral lines. Is defined as its ability to distinguish. It's defined as its ability to distinguish two very close spectral lines. Two very close spectral lines of wavelength lambda and lambda plus d lambda. Of wavelength lambda and lambda plus d lambda. And is numerically defined as আর করতে পারি numerically given by. So and the numerical definition of this one is lambda by d lambda. I will show you why. কেন আমি তোমাকে বলে দেব। Lambda and lambda plus d lambda. You see that in the previous case, in the telescopic case, the definition was 1 by d theta. And this case you see that it is 1 by d lambda, because in the telescopic case you need to separate two close objects. দুটো অবজেক্টের মধ্যে separation, and the separation between two objects was how much? This is from O1 and this is from O2. So what is the separation between them? It was d theta. So the resolving power is the inverse of that. That is 1 by d theta. কাজ শেষ, all over. And now you see For the grating case, it has to distinguish between two lines. One of the line is of wavelength lambda and another is of wavelength lambda plus d lambda. It has to separate this. So here the definition should be in line with this. So if I try to maintain parity with this one, so in case of grating, the definition should be 1 by d lambda. তাহলে এখানে 1 by d lambda হবে, but this has a problem. So this gives it a unit of angstrom inverse. এটা unit চলে আসে angstrom inverse, but you see that magnifying power, resolving power, or any power in physics that do not have any unit. So that is, if I want to maintain the similarity with the other definitions of resolving power and the other definitions of power in optics, যেটা আমার মনে পড়ছে, one which I remember at this present moment is the magnifying power, which is defined as the v by u, object distance by image distance. You have read in your school days. So you see that this is dimensionless. So similarly, in order to make it dimensionless, I take the help of lambda, because lambda is the reference wavelength. এবার ল্যামডাটাই কেন নিচ্ছি? তুমি বলবে যে স্যার ল্যামডাই কেন নিচ্ছেন? Why are you taking lambda? I am taking lambda because lambda is already present in the system. Lambda is the reference value. So that is why I define it in that way. But once again, I would like to put stress upon that the basic definition is d lambda. Basic ব্যাপারটা হচ্ছে d lambda, right? The ability to separate out two different wavelengths. মানে the value of the d lambda that comes out to be least for the instrument, the better is that instrument for resolution. যেই যন্ত্রের d lambda যত ছোট আসবে, তার রেজলিউশন ক্যাপাসিটি তত বেশি। আমি আবারও বলছি, যেই যন্ত্রের d lambda যত কম আসবে, তার রেজলিউশন এবিলিটি তত বেশি। Lesser the value of d lambda that comes out after calculation, lesser the value of d lambda that comes out after calculation, better is the resolution of that instrument. And now in order to do something else, that is according to human perception, this is smaller, so 1 by d lambda will be greater. So greater the value, greater is the resolution. So in order to maintain, in order to get at par with our standard definition of power, ক্ষমতা যত বেশি তত ভালো, more the power, better is the resolution. So that is why I define 1 by d lambda, which is clear to you. And then I take a lambda over here to make it dimensionless. Dimensionless করার জন্য হচ্ছে finally lambda, ঠিক আছে? But basic part is, I have said, d lambda. Basic idea is d lambda. এইটুকু থাকবে, এটা থাকবে, ঠিক আছে? Is numerically given by this, ঠিক আছে? আচ্ছা, গ্রেটিং খেয়াল করে দেখো, গ্রেটিং এর ম্যাক্সিমা মিনিমা কন্ডিশন গুলো মনে করো না, you remember the condition. Recall the condition for nth principal maxima for lambda. The condition for nth principal maxima, the condition for nth, the condition of nth principal maxima, the condition of nth principal maxima for wavelength lambda will be, for wavelength lambda will be how much? For wavelength lambda will be, so that is given by এই nth principal maxima condition কি আছে? What is the condition of nth principal maxima in the grating? So it is a plus b, তাই তো? a plus b তো ছিল, a plus b sin of alpha, a plus b sin of alpha is equals to some n lambda, তাই তো কন্ডিশনটা? দাঁড়াও একবার, sin of theta করে দাও, এখন alpha দরকার নেই। So the condition for nth principal maxima is this: a plus b sin theta is equals to n lambda. You know this one, where a plus b is called the grating element. A plus b is the grating element, we know it, and theta is the angle of diffraction. Theta is the angle of diffraction. Fine. This is the condition for the nth order principal maxima for wavelength lambda. Now, thus the condition of nth maxima, nth principal maxima for wavelength, এবার lambda plus d lambda এর জন্য কর, for wavelength lambda plus d lambda, what will be that? For lambda plus d lambda will be, now lambda plus d lambda will be bit separated, lambda plus d lambda একটু সেপারেট হবে, তো সেই জন্য তুমি লিখছো a plus b sin of theta plus d theta, you write, and you write n of lambda plus d lambda. So whatever did I do is that I change lambda to lambda plus d lambda and theta to theta plus d theta. So lambda টাকে lambda plus d lambda করেছি, theta টাকে theta plus d theta করেছি। ঠিক আছে, এইটা হচ্ছে লাস্ট ক্লাস থেকে নিয়েছি। This is what I have taken from the last classes of grading. Condition of nth principal maxima. So the condition for nth principal maximum is a plus b sin theta equals to l lambda. And if I go it for another wavelength lambda plus d lambda, so definitely the angle of diffraction will change to theta plus d theta. Right? Understood? Okay. Now you write the Rayleigh's criteria. এবার Rayleigh's criteria মনে করো যে কখন এটা রিজলভ হবে, when these two wavelengths will be resolved. The two wavelengths will be just resolved. The two wavelengths will be just resolved if the nth order, if the nth order principal maxima of lambda plus d lambda coincides with the first minima, adjacent to the nth principal maxima, coincides with the first minima adjacent to the nth principal maxima of lambda. Now this is quite non-trivial. So বেশ জটিল কথা বলেছে। I have said a number of things over here. If the nth order principal maxima of lambda plus d lambda, which is basically given by equation 1, coincides with the first minima adjacent to the nth principal maximum, this condition I have derived on the last class, nn plus 1 of lambda. ভালো করে বোঝো, the two wavelengths will be just resolved if the nth order principal maxima. Now the difference with grating and other treatments is that in the other treatments there is only one principal maxima. অন্য ট্রিটমেন্ট আর গ্রেটিং এর সঙ্গে পার্থক্যটা হচ্ছে অন্যান্য ট্রিটমেন্টে প্রিন্সিপাল ম্যাক্সিমা একটাই থাকে, যেরকম ধরো সার্কুলার অ্যাপারচার, সিঙ্গেল স্লিট, হাউ মেনি প্রিন্সিপাল আর দেয়ার, দ্যাট ইজ অনলি ওয়ান প্রিন্সিপাল এন্ড দিস আর অল দ্য আদার ম্যাক্সিমা, এগুলো অন্য ম্যাক্সিমা। বাট দ্য ইন দ্য গ্রেটিং কেস ইউ নো there are many such principles. These are the secondary maxima, this is another principle, this is another principle, and so on the system goes on. So in the grating there are many other principal maxima. So now the question is that which principal maxima you are using for your resolution. So if you are using this principal maxima, then you should take this particular minima. বুঝা যাচ্ছে? If you take this principal maxima for your resolution, then you should take this particular minima. That is the minima adjacent to the nth order principal maxima. Because principal maxima মানে basically the zeroth order. In general, principal maxima মানে তোমার zeroth orderটা, but grating এর ক্ষেত্রে তো একটু আলাদা হয়। In the grating you know that there are many principal maxima, not only one principal maxima, there are many principal maxima. So excuse me, so for the case of grating, the first minima that you consider is with respect to this one. এটা কিন্তু এইটার রেসপেক্টে করতে হবে। আর তুমি জানো এটা যদি nth order principal maximum হয়, if this is the nth order principal maximum, so then this minima is nn plus 1, তাহলে এই মিনিমাটা কিন্তু nn plus 1 করতে হয়। যেরকম এটা যদি 0th maxima হয় তাহলে এটা নিশ্চয়ই 1 আসার কথা, এবং 1ই আসবে তুমি যদি স্মল n ক্যাপিটাল n plus 1 এই ফর্মুলা যদি ইউজ করো, if you use this formula, because 0th মানে I put 0 over here, so it comes out to be 1. But if it is your second maxima, second principal maxima, so then it will come out to be 2 into capital N plus 1, where capital N is 1 by A plus B, that is at your control. So capital N টা তোমার কন্ট্রোলে আছে, how many lines are there per unit length, or how many rulings are there per unit. Okay, বোঝা গেল মোটামুটি ভাবে কি বলতে চাইলাম। তার মানে এখনকার ফার্স্ট মিনিমা মানে নরমাল ফার্স্ট মিনিমা নয়, ফার্স্ট মিনিমা adjacent to the nth principal maxima, because grating has number of principal maxima. grating এ তো অনেক principal maxima, তাহলে তুমি কোন ম্যাক্সিমাটা ইউজ করছো সেটার উপর ডিপেন্ড করবে কোন মিনিমাটা। if you use the nth principal maxima, then the first minima adjacent to that, which is given by nn plus 1. I hope that you have understood. আচ্ছা, এবার কার সাথে কাকে কোইনসাইড করাচ্ছ সেটা দেখে নাও, কোনটার ম্যাক্সিমা কোনটার মিনিমা কোইনসাইড করছে দেখে নাও, which maxima and which minima coincides, just have a look. nth order principal maxima of lambda plus d lambda, so তার মানে lambda plus d lambda হচ্ছে maxima, so lambda plus d lambda, don't write it, this is for my reference, this is the principal maxima and lambda is for minima. So the minima condition will be put in lambda and the principal maxima condition will be put in lambda plus d lambda. Okay, so here you have coincides with the first minimum of this one. Now what is the condition of the minimum? So এটাকে আমরা বলে থাকি Rayleigh's criteria. This is my Rayleigh's criteria. এটাই তো Rayleigh's criteria. Coincide মানে Rayleigh's criteria. That is you should write it properly. So Rayleigh's criteria আমাদের লিখে দেওয়া উচিত সব সময়। আচ্ছা এইবার আর এখানে একটু লিখে দিও ব্র্যাকেটে where n is what, where capital N is 1 divided by a plus b, total number of rulings. Capital N is actually the total number of rulings. A plus b is the grading element and capital N is the, no, I am making mistake. Is it so? হ্যাঁ, capital N is not a plus b, it is n dash, ওটা তো n dash ছিল। where n is the, n টা কি, where n is the total number of rulings, n হচ্ছে total number of rulings, মানে সিঙ্গেল স্লিটে যেটার ভ্যালু হচ্ছে 1, the value is 1 for single slit, 2 for double slit and n 100 200 something for that grading এর জন্য। সরি, n is not 1 by a plus b, so that is n dash, ওটা তো n dash ছিল। n is the total number of rulings, you know it from the last class, you just match up, ওখান থেকে match up করে নিও। আচ্ছা এবার কন্ডিশনটা লেখো, the condition for minima in a grading. What is the condition for minima in a grading? The condition for minima in a grading, the condition for minima in a grading, what is the condition for minima in a grading? এই grading এ minima condition বলো, কি condition ছিল করে দিয়েছি, মনে করে দেখো, n of a plus b sin alpha that was equals to some m lambda. This is for wavelength lambda and in a direction of alpha. In the wavelength lambda and direction is alpha. And you know that what values of m are not possible? M equals to 0 is not possible because it gives the 0th order principal maxima. M equals to plus minus n is not possible because that gives the nth principal maxima. So the values which are not possible is 0, plus minus n because it gives the first principal maxima, then plus minus 2n is not possible because that gives the second principal maxima, and so on and so forth, right? And in between you have the minima, মাঝখানে তোমার মিনিমা গুলো আছে। So this is the condition for minima in a grading. But I need minima for whom? আমার minima কার জন্য লাগে? I need minima for lambda. Okay, this is lambda, fine. I need the value of m, so m is this one, so I will be using this for the m, and the minima will occur in which direction? The minima will be coinciding with whom? Coinciding with the maxima of lambda plus d lambda. The minima will be coinciding with the maxima of lambda plus d lambda. Now the question is, what is the direction of the maxima of lambda plus d lambda? Lambda plus d lambda maxima ta kon dike hoyeche? The maxima of lambda plus d lambda has occurred in the direction of theta plus d theta. Try to have a look. The maxima for lambda plus d lambda has occurred in the direction of theta plus d theta. And if it needs to coincide, এবং যদি coincide করতে হয় তাহলে the minima should also occur in this direction, that is this alpha should also has this value only, তাহলে আলফার ওই ভ্যালুটাই হবে। আরে ভাই coincide করতে হবে, তো একটার উপর আরেকটা পড়বে, তো একটার উপর একটা তো তখনই পড়বে যখন থিটা ভ্যালুগুলো সেম হবে। so one will be overlapping on the other only when the angle of diffraction is same at the same angle, otherwise how will it occur? So that is why the minima will be found in which direction? In the direction of theta plus d theta, and then only it will coincide with the principal maxima, nth order principal maxima of lambda plus d lambda. So I write it next, তাহলে সেটা লিখছি, as this minima should coincide in a direction, as this minima should coincide in a direction given by equation 1, coincide in a direction given by equation 1, equation 1 এর ডাইরেকশনটা দেওয়া আছে, it is theta plus d theta, so we must set, what should I set then? So we must set, so for minima actually, so for minima we must set, minima means the first minima adjacent to the nth principal maxima, we must set, so capital N a plus b is untouched, কোন ডাইরেকশনে নিতে হবে মিনিমাটা? what is the direction of the minima? The direction of the minima is theta plus d theta because the maxima is in this direction and I need coincidence, I need overlapping. আচ্ছা, How do you calculate the order of the minima? The minima which is adjacent to the nth principal maxima. Nth principal maxima পাশে যে minima তার সেটা কি করে ক্যালকুলেট করে? The formula I have shown to you in very details on the last classes. এর আগের ক্লাসে দেখিয়ে দিয়েছি, you understand why, and then I write lambda because the minima is for lambda. So minimata lambda এর জন্যই বের করতে হয়। তাহলে এই তো আমার হয়ে গেল কাজ। So this is my equation number 2. So now you just compare equation 1 and 2, your task is done. Comparing 1 and 2. Comparing 1 and 2. 1 আর 2 compare করো, তোমার কাজ শেষ। So you see that a plus b sine of this one and this one is a extra capital N. So let us multiply equation 1 by capital N. Equation 1 কে যদি capital N দিয়ে multiply করো, so then equation 1 and 2 the left hand side becomes identical. So that is why I write, তো সেই জন্যই আমি লিখছি from equation 1 I write capital N, I multiply both sides by capital N. So capital N small n, so capital N small n lambda plus d lambda. I multiply equation 1 by capital N on both sides. And equation 2 I leave as it is. Equation 2 যেমন আছে ছেড়ে দাও। Equation 2 you leave as it is. Right? You leave it as it is because you understand, you are trying to compare it. So small n capital N lambda cancels out. So I have small n capital N d lambda and this one is lambda. So এই তো তোমার থাকে. So this is what you have. Or I have this lambda by d lambda is equals to small n capital N. So lambda by d lambda is equals to small n and capital N. So that is what do I have at this moment. So এটাই হচ্ছে আমার পুরো স্টোরি যেটা আমার কাছে আছে। So that is the entire story that I have with myself. I hope that you are getting it. তোমরা নিশ্চয়ই বুঝতে পেরেছো। Is it clear to you? So lambda by d lambda is equals to small n capital N. So that is the resolving power of a grading. So that is the resolving power of a grading, right? So this small n capital N must at least have this value of lambda by d lambda, right? So এই হচ্ছে তোমার পুরো স্টোরি। This is the entire story that you need to have. Now just let me give you an idea over here. So lambda 1 is 5890 angstrom. These are called the sodium D lines which we usually have in our laboratories. এটা ল্যাবরেটরিতে আমাদের আছে, the experiment on resolving power. So lambda 1 and lambda 2 is given to you. So this d lambda is only 6 angstrom. So you see that your value of lambda by d lambda, if you calculate this one, 6 divided by, so sorry, 6 will be in the denominator. Now people will ask you what to use for lambda. অনেকেই তোমায় বলবে তাহলে lambda কোনটা ইউজ করবি, এটা করবি না এটা করবি, which to use? I say you use the average. আমি বলি অ্যাভারেজটা ইউজ করো, তাহলে সেফ থাকবে। হ্যাঁ, তুমি যদি 5890 করো কিচ্ছু ক্ষতি হবে না, বিকজ ইন কম্পারিজন টু দিস 5800 and this 6, in comparison to 6, এই 6 এর কম্পারিজনে 5890 করো আর 96 করো, কিছুই চেঞ্জ হবে না, there will be no such change, but you use the average. তুমি অ্যাভারেজটাই করো and this will come out nearly to be 982. এই ফ্যাক্টরটা মোটামুটি তোমার 982 আসে, ঠিক আছে? So that is why you are supposed to have small n capital N greater than equals to 982. So এই small n capital N প্রোডাক্টটা দেখো, এটা তো তুমি চেঞ্জ করতে পারবে না, this one is fixed for this arrangement. So if I give you this lambdas and this d lambdas, তোমাকে যদি আমি এই lambda d lambda সিস্টেমটা দিই, if I give you this system of lambda and d lambda, so then the left hand side is fixed and the right hand side should be able to give you this number. এবং রাইট হ্যান্ড সাইডটা তোমায় যেন এই নাম্বারটা দিতে পারে, দ্যাট ইজ 982. সো দ্য রাইট হ্যান্ড সাইড শুড বি এবল টু গিভ ইউ দিস নাম্বার, দ্যাট ইজ 982. ওকে, সো ইফ ইউ হ্যাভ টু গেট 982 অন দ্য রাইট সাইড, সো দ্যাট ইজ হাউ ইউ শুড অ্যারেঞ্জ ইউর স্মল এন এন্ড ক্যাপিটাল এন। সেইভাবে তোমার স্মল এন আর ক্যাপিটাল এনটা অ্যারেঞ্জ করতে হয়। ইট মে সো হ্যাপেন দ্যাট ইউর স্মল দিস ক্যাপিটাল এন ইজ 500. So you see that in the first order resolution is not possible. So 1 into 500 gives you 500, but you need at least 982. But তোমার তো 982 লাগবে, so resolution will be not possible. But once you go to the second order, you will see that resolution is possible. Second order গিয়ে তুমি দেখতে পাবে resolution কিন্তু possible হচ্ছে. The resolution is possible in the second order. Okay, so that is the idea which I am trying to share with you. So এই আইডিয়াটাই আমি তোমাদের সাথে শেয়ার করতে চাইছি। I hope that you are understanding the issue. So আশা করি তোমরা বুঝতে পারছো যে আমি কি বলতে চাইছি। So what I actually mean to say over here, the things are, I hope that you are getting it. So সেটা হয়তো তোমরা নিশ্চয়ই বুঝে উঠতে পারছো, ঠিক আছে? So this is all about my discussion. So এইটাই আমার ডিসকাশন তোমাদের সাথে করার ছিল। So this was the discussion that actually I needed to do with you and I have been successful enough in doing so, এবং সেটা আমি করেছি। আর এই জায়গাটা একটু খেয়াল করে নেবে, this actually helps to solve the numerical examples, that your small n capital N product should be greater than this 982 for this particular system, and this can be adjusted by using, you see that for a grating capital N is fixed, একটা গ্রেটিং এ ক্যাপিটাল N তো ফিক্স হবে, তাই না? একটা গ্রেটিং এ তো ক্যাপিটাল এন ফিক্স, ফর এ পার্টিকুলার গ্রেটিং ইউর ক্যাপিটাল এন ইজ ফিক্সড, and if this capital N is fixed, so then for good resolution you need to go for higher orders. তো সেই জন্য তোমাকে হায়ার অর্ডারস এ গিয়ে তোমার রেজলিউশন করতে হবে। Okay, so suppose this capital N is appearing to be something about some say some 500 or something like that. So capital N টা ধরো তোমার 500 তোমাকে দেওয়া হয়েছে, so 500 into 1 doesn't give you 982, so resolution is not possible in first order, so you have to go for the higher orders. Okay, so think about this issue, so এই ইস্যুগুলো নিয়ে একটু ভাববে, and what has the problem that has happened to me, so don't get confused with N and N dash. So N is the total number of rulings that is present within the grating. Suppose this is your grating, so these are the slits over here, so how many slits are there, that is what is given by capital N. So how many slits are there, that is actually given by capital N, and N dash is your number of rulings per unit length. So N dash টা হচ্ছে 1 divided by A plus B, that is the total number of lines per unit length. So don't be confused with this, so this actually confuses a few times, so please avoid it. So here I will be concluding my discussion on resolving power. Thanks to all of you for your kind attention.